Hi, I'm Alexandria Clark. I'm a third year undergraduate student at Texas Tech University in the College of Arts and Sciences. And this is my presentation on my research on X-ray galaxies for a new star observatory proposal. So I'm just going to start by taking you through my poster here. As an introduction, the New Star Observatory is a high-energy X-ray telescope with the unique ability to operate at energy levels above 10 keV. As there is a lack in hard X-ray galaxy data, I aided in selecting galaxies for a New Star proposal to study galaxy spectral energy distributions and X-ray source populations, in order to better understand X-ray galaxies and the correlations between their properties. Using the data from the two catalogs that we used, which were Legis and Hecate, I predicted the luminosities, fluxes, and exposure times of the galaxies and plotted the data for visual comparison. After narrowing down our parameters, my team and I created a list of about 5 galaxies and wrote a proposal for the New Star Telescope observation time. If our proposal is selected, we will use this data to further our knowledge of X-ray galaxies and even the early universe. So just a little bit more background. As mentioned before, New Star is the only Earth-orbiting high-energy X-ray observatory operating at energy levels above 10 keV. Its mission time is coming to an end in the next few years, so we wanted to take advantage of what little time it had left by studying some X-ray galaxies. We used the Vuelich et al. 2018 paper for a comparison of some galaxies. It is a paper on a study of sample galaxies observed by a new star in the 4 to 25 keV band. The specific star formation rates were calculated using constants and equation in the paper. The Hecate catalog is a list of galaxies at a distance less than 200 megaparsecs and lists their properties as well, such as the mass, distance, location, etc., of all the galaxies. Legis is a similar catalog. It just is of galaxies observed in the UV band at a distance less than 12 megaparsecs. So studying these X-ray galaxies is important to understanding the development of the early universe, as high mass X-ray binaries played a key role in heating the primordial intergalactic medium. The process of selecting these galaxies started with a review of the new star already observed galaxies in the Vuelich et al. 2018 paper. These were used as a comparison to the candidate galaxies later on. So we assessed the galaxy catalogs Hecate and Legis. We considered about 74,000 galaxies from Hecate, but reduced that sample size to about 1,700 by only considering galaxies at less than 15 megaparsecs. Then we further reduced that sample to about 71 galaxies with specific star formation rate, which is the star formation rate divided by the mass above 0.4. Then we did the same thing with the Legis catalog and found about 12 galaxies. I also calculated the expected luminosities, fluxes, and exposure times of all these galaxies, and then plotted them all for visual comparison and helping select the best candidates. We only considered galaxies with exposure times less than 250 kiloseconds. We didn't want to overuse the time of New Star because they're very selective in how they use their time. So we reduced the candidates down to about 14 Hecate galaxies and about 5 Legis galaxies. Then we had to do some research on the galaxies to eliminate the ones with strong indications of active galactic nuclei and ultraluminous X-ray sources, which are objects such as like supermassive black holes. Then we chose the most interesting galaxies for a new star proposal of about 1 megasecond of observation time. Here I have our most important plot. The galaxy's stellar mass versus star formation rate. It shows all of the Hecate galaxies in the purple triangles and all the Legas galaxies in the blue diamonds. If they're filled in, that means they've already been observed by a new star, both in the Legas and Hecate catalog. I also have plotted the Bulic galaxies already observed by a new star in the red dots, and in the yellow dots, those are the new star already accepted galaxies. The candidates are all the candidates we started looking at after we narrowed some parameters down are the ones circled, the Hecate ones in the red and the Legas ones in the blue, both having high specific star formation rates and exposure times exposure times less than 250 kiloseconds. The dotted lines are kind of just for reference of specific star formation rates, as the yellow one is the 0.4 specific star formation rates. The axes are in logarithmic form, just for a better representation. And this plot was made in Python. I use Python a lot throughout my research. All the figures and calculations were made using Python, and XBEC, which is a program for studying spectral distributions. And in this case, was used to calculate mainly exposure times for galaxies. In the end, after narrowing down all of our candidates, we came up with these 5 galaxies. Here's some images of them, and I'm going to talk about just a couple of their features. So NGC 5253 here is an irregular galaxy with a distance of about 3.2 megaparsecs, has a star formation rate of about 0.1 and a predicted exposure time of about 400 kiloseconds. This is NGC 4656. It's also known as the hockey stick galaxy and is a barred spiral galaxy interacting with another galaxy, NGC 4657. It has a distance of about 5.5 megaparsecs, star formation rates of 0.4 solar masses per year, and an exposure time of about 173 kiloseconds. Next, we have NGC 4449, which is also known as Caldwell 21, and is an irregular Magellanic type galaxy with a distance of 4.3 megaparsecs, star formation rate of 0.94, and exposure time of 273. NGC 4605 here is a barred spiral galaxy with about a distance of 5.7 megaparsecs, star formation rate of 0.4, and exposure time of 350 kiloseconds. Last is NGC 4490, which is also known as the Cocoon Galaxy. It's a barred spiral galaxy with a distance about 7.2, star formation rate of 0.19, and exposure time of 296. In the end, we successfully chose 5 galaxies, wrote a proposal for the new star observation time at a total of about 1 megasecond. And these galaxies were chosen based on their potential for X-ray data. They're all very luminous nearby galaxies with high star formation rates and will be essential assets to furthering our understanding of X-ray galaxies and the beginnings of the universe. So I would like to thank Dr. Anne Hornschmeyer, Dr. Thomas Macarone, Dr. Nevin Bulick, and Dr. Mihoko Kita for their guidance and mentorship throughout this project. I would also like to thank the Honors College Undergraduate Research Scholars Program supported by the CH and Helen Jones Foundation. Thank you for listening to my presentation. I'm Alexandria Clark. Thank you again.